Did I get all the questions? 19, 27, 39, 41, 47? All right. Oh, let's just check these out. Starting with 19. Okay, probably on 19, the easiest way to do this is to go ahead and distribute that numerator. Is that what y'all tried? Yeah. Okay, but you just got bogged down? Okay. X squared plus x plus 1 over x squared. Now what x cubed. What I cannot do is reduce anything yet because I don't have any common factors. And so you might say, well, why don't we use the quotient rule? We could, but it's going to involve something that we haven't done yet. We would have to use the quotient rule within the product rule. Because when I took the derivative up top, I'd have to use the product rule. So I think it'll be easiest if we just go ahead and distribute and then go from there. And we may have to use the quotient rule then. Okay, so this is x cubed plus x squared plus x minus x squared minus x minus 1. Y'all, please watch and make sure I don't make a dumb mistake. Okay, this becomes x cubed. X squares will cancel, x's will cancel, just minus 1 over x cubed. Now, as tempting as it is, x cubes can't cancel because x cubed is not a factor of the entire numerator. So at this point, I will use my quotient rule. Do you remember the rhyme? Low D high minus high D low
over everything squared below.
over.
That's like right.
Over, now you have messed me up. Over the square of what's below. Okay. No, I was just trying to think of the words that I was using, and then my brain got jumbled. Okay, low D high minus high. Now make sure that that x cubed minus 1 goes in parentheses because there's more than one term. And then D low over x cubed squared. Does that become x to the 5, x to the 6, or x to the 9?
X to
6. Power raised to another power. We multiply exponents. Okay, so the derivative is 3x to the what? 5th minus 3x to the 5 again plus 3x squared over x to the 6. Okay, then I do have these like terms that just cancel out. So I end up with just 3x squared over x to the 6. And that reduces to 3 over x to the 4. How else can I write that with a negative exponent? 3x negative 4. Okay. All right, are we good on that one? Okay, 27. Find an equation for the line tangent to the curve at the given point. 2x at x equals 1. Okay, equation for the tangent line. So to write that, I need the slope, which I will find the derivative for that, and I need a point. Well, I have half a point. I have the x coordinate. So to find the y coordinate, I will do what? Plug 1 into the original function. So let's see, can we do this mentally? 1 cubed is 1. 1 plus 1 is 2. Over 2 times 1. 2 over 2 is 1. Okay, so now we have our order pair. We have to find our slope. We will do that using the derivative, and we'll have to use quotient rules. So low D high minus, this is almost just like what we did, high D low over the square of what's below. All right, let's distribute out. That becomes 6x cubed minus 2x cubed minus 2 over 4x squared. Good. Okay, like terms, the derivative is 4x cubed minus 2 over 4x squared. Nothing to reduce there unless you decide to divide everything by 2. But we're just plugging in a 1, so I'm just going to leave it because subbing in a 1 isn't so bad. So I'm finding y prime of 1. So every place that an x appears, I am replacing it with a 1. Yes, ma'am? Sure, I'll send you. Oh, okay. Qualifies? Okay. A good candidate. Yeah, absolutely. Okay, I'll send it. All right. Walker, you have been summoned to Miss Armis's office. All right, let's see. What does this give us? 4 minus 2 is 2 over 4 times 1 is 4. So what is our slope? 1 half. If you're going out the front doors, those little steps that go up, like 3 steps, go in that door right there. Okay, so we know our slope is 1 half. We know the point is 1, 1 that it goes through. So y minus 1 equals 1 half times x minus 1. I'm going to leave it, but you can, of course, distribute and keep going and put it slope percent. How many of you are okay leaving it like that for now that you didn't think you would be? You're just like, yeah, okay, I can live with that. All right, 39. Are we okay with 27? 39. What would that be? Trent? What's 30 in Spanish? Treinta? Treinta y nueve. My brain is so weird. Why did that pop in my head? Find the points on this curve. 2x cubed minus 3x squared minus 12x plus 20, where the tangent is parallel, use those symbols for parallel, to x-axis. Okay, so they're throwing some curveballs at us. Here's our x-axis. If anything is parallel to the x-axis, then it is horizontal. Any horizontal line has a slope of 0. So it's just a sneaky way of saying where is the slope? 0. Okay, well, I'm going to find that by finding something that represents the slope, that's the derivative, and just setting it equal to 0 and then solving that for x. So if y'all have a question over anything I just said, let me know. Stop me. There's our derivative. If I wanted to know where the derivative was 8, I would set it equal to 8. So any time I want to figure out where is the slope of this, then I set the derivative to that number. Okay, what would you do? I think I'd like to divide by 6. What about that? Because it'll make everything smaller, I want that to make it easier. Generally, it'll make it easier. But 0 divided by 6 is still 0. Then that becomes x squared minus x minus 2. Does that factor? It's just a little bit easier to see that it factors. So my factors would be what? Minus 2 and plus 1. Okay, so I'd set each of those equal to 0 to solve, and that would give me x equals 2 and x equals negative 1. Are y'all okay with that? I left out a step there where I set them equal to 0 and solved. And I think we've answered a question, haven't we? No, not quite. Find the points on the curve. Okay, so this would answer the question, find the values of x where the tangent is parallel to the x-axis. But if I want the points, then I have to go one step further and find the y coordinates that go with those x's that we just found. Okay, what do I substitute those into? Original function. And I'm going to just tell you what my book has, and you'll tell me if this is what you got. 27 and 0. Okay, so that's just subbing in to original sub into y equals, not the derivative. Okay, are we good? Am I going too fast? Okay. All right, 41. Find the tangents of Newton's serpentine. This function is fancy because it has a name. Newton's serpentine. 4x over x squared plus 1. Does that denominator factor? How do I know? Sum of two squares. Yep, will not factor. Okay, find the tangent at the origin and the point 1, 2. At origin at 1, 2. Okay, so these are 2 points that are on this function. I just want to figure out what the tangent line is at those points. How am I going to do that? To write the equation of a tangent, what do I need? Slope and a point. I have the points. I must find the slope to go with each one of those because they might not be the same. They might, but probably not. So I'm going to use my derivative to represent the slope, then plug each of those in separately to find the individual slopes that go with each point. Okay, low, t high minus high, d low, over, okay, all that has to go in parentheses and square it. Okay, I'm not going to square the bottom. I'll just sub those numbers in without squaring, but I think I will clean this up a little bit. 4x squared plus 4 minus 8x squared over x squared plus 1 squared. Okay, so y prime is negative 4x squared plus 4 over x squared plus 1 quantity squared. Okay, so that is an equation that I can use to find the slope anywhere on that curve. Well, I want to find the slope at 0, 0. So in order to find that, I'm going to just sub in that x coordinate of 0 into this. Negative 4, 0 squared plus 4, 0 squared plus 1 quantity squared. That whole term there is 0, so I end up with 4. That's just 1. 1 squared is still 1, so my slope is 4. Okay, so now I want to write the equation of this tangent. Y minus 0 equals 4x minus 0. Which is fine. We can leave it that way. Or that's just y equals what? 4x. Okay, so all of this is for the point 0, 0. Now I want to find the slope at the other point that they gave us, 1, 2. So here's my formula for slope. X is 1 at this point, so the slope will be negative 4 times 1 squared plus 4 over 1 squared plus 1 quantity squared. Okay, that's negative 4 plus 4 is 0. Doesn't really matter what I get down there. 1 plus 1 is 2, and do go to 4, but that slope is just 0. So I have slope of 0 going through this point. So y minus 2 equals slope times x minus 1. But then this whole right side is just 0. So y minus 2 is 0, which is the same as y equals 2. So all of that goes with the ordered pair 1, 2. A little bit of work on that one, huh? Any questions on that? What confused you on that one? There seemed to be a lot of confusion with that one. Just not knowing what to do with it.
That's usually
It makes sense.
Okay.
When it says find the tangent, that means find the
Equation of the tangent line. Okay, we're good. All right, 47. Free fall. When a rock falls from rest near the surface of the earth, the distance it covers during the first few seconds is given by the equation S equals 4.9 t squared. Okay, t is representing time, S is representing distance there. It says distance in meters, and t is time in seconds. Find ds dt. ds dt, what does that mean? The derivative, okay. So bring your 2 down. What is 4.9 times 2? 9.8. Reduce the exponent by 1, and it's just t. What would the units be? Distance over time. Meters per second. And then it says find d2s over dt2. Okay, remember I said even though those look like squares, they're not. That means what? Second derivative. So I could also write this as s double prime. Second derivative of s. Okay, so if I took the derivative of 9.8t, what would that be? 9.8. What would the units be? Okay, the derivative is in meters per second, but then I took that with respect to time again. So it's really meters per second, which is over 1. And so normally we just write that 9.8 meters per second squared. Okay, so this would be a rate for velocity, and this would be a rate for acceleration. Why do you think it's just that coefficient? It's the acceleration of
an item due to gravity.
gravity. Yes. And that plays nicely into what we're going to talk about today. Okay, let me stop this one and then we'll